In this case study review, we will provide highlights of a proof of concept engagement where DataWalk was used to provide a highly agile, rapid prototyping environment. In this case, the customer was very sophisticated and had a full set of advanced tools, but they had an issue in that they wanted to test various hypotheses across many data sets, and this was impractical as it would require an expensive integration and data preparation project just to do the testing. So we came in to do a POC to quickly enable testing of these hypotheses. We built from scratch an integrated prototyping environment spanning 9 different data sources and enabled the customer to execute 98 different analyses to test a range of hypotheses, all in just 3 days. In this video, we will provide a brief look at some of the highlights of this case. Here's what the finished product looked like in the DataWalk application. This is the DataWalk Universe Viewer, which is the analytical interface that is being used for building a visual representation of all the data in the system for exploration and analysis. It is important to note that this is a working environment with real customer data. This environment is a result of an iterative process of working with the customer and engaging their users, and can easily be changed as needed without downtime. Each icon represents a data set that was generated from one or more data sources. As you can see, this environment is presented in business terms based on how users want to see the data, not based on the structure of the sources or the specific questions and analyses that are intended to be explored. This particular case happened to be in the auto insurance sector, so you can see data sets like claims, policies, and so forth, but the concepts are applicable across any use case. At any time, you can view underlying data for any data set. The lines between the data set icons are connections, which are the business relationships between objects based on business rules. There can be many connections between any 2 data sets, and connections can easily be added, deleted, or modified. As we will show in a minute, this structure is queryable, such that users can instantly ask and answer both simple and complex questions without knowing SQL or a programming language. We should also mention that this section of the screen is from the DataWalk application, and for the purposes of this video, we've added a simple timeline overlay at the top, and we've also added an overlay showing the number of analyses performed. Now we will rewind to the start of the project and discuss how we got to this result. On day 1, we first focused on defining the initial questions that users wanted to answer, and then identifying the systems from which data should be pulled in order to create the first iteration of the environment. This allowed us to determine that in order to prototype the first few analyses, we needed to have data for customers, claims, vehicles, and policies. We first loaded information about claims, which came from 2 different systems, so that they could be presented as a single integrated claims dataset. DataWalk can analyze data from various types of sources, including databases, large flat files, JSON, XML, and others. The system supports automatic incremental imports, and the ingest process does not require any downtime. In the customer environment, there were sometimes well-defined relationships and identifiers of the elements. For example, claim ID was propagated across multiple systems, and DataWalk automatically discovered that relationship and suggested it for the user to consider. However, there are many situations when there was no common key, or where the data is dirty, and in such cases, various other sophisticated DataWalk techniques can be used. For example, when creating connections between vehicles and owners based on a vehicle identification number, or VIN number, we see that a few owners were not connected with vehicles. We were able to connect these outliers by using another rule, specifically fuzzy matching on the VIN numbers. This is one simple example illustrating how DataWalk can often enable you to get trusted results even with dirty data. At this point, these 2 base data sets have been blended on the fly. In DataWalk, we do this via connections, and there's no physical merge. We quickly reviewed objects and connections to ensure rules were correctly established and objects were properly connected, and any connections that needed to be modified were changed on the fly with a few clicks. Now we're still on day 1, and at this point we have built a simple logical structure with real customer data from just a few sources that enables the first set of hypotheses to be tested. We can query the system and test hypotheses by filtering data sets and their connections. For example, we are curious how many claims are associated with accidents involving cars more than 10 model years apart, where the accident happened within less than 4 days before the policy expired, and where the victim has more than 1 policy. We instantly see that there are more than 300 such claims. This visualization updates whenever source data is updated in DataWalk, and this can be done automatically as frequently as desired. On day 2, we further iterate on the environment. We modified a few of the connections, and added a new connection within the existing structure. This took just a few minutes. As users were able to answer the initial questions on day one, they're better able to identify which new sources should be integrated to answer the next set of questions. In DataWalk, you can extend the view of the universe viewer by adding new sets in seconds without interrupting system operation. The ability to iteratively develop and extend the environment and analyses with real data is a key reason why projects can be completed very quickly with DataWalk. Next, we integrated 4 additional data sources: police reports, which are associated with claims, compensation amounts, vehicle values, and bank accounts associated with payments of premiums and claims. That allowed us to add additional parameters that users wanted to use in order to test the next set of hypotheses. With the additional data sources, we were able to enrich our content with additional rules, such as the difference in value between vehicles involved in an accident. You can see that with DataWalk there is no need to predefine a rigid, all-inclusive, future-proof environment, a process that can take months or years with traditional approaches. Instead, a highly flexible environment is instantly extended and modified as desired. And by keeping the analytical data model on the business level, here with constructs such as claims, vehicles, and so forth, the cost of modifying or adapting to changing business requirements is dramatically reduced. To test the customer's various hypotheses in detail, the data was analyzed using histograms, charts, maps, and network graphs. During day 3, we enabled the customer to test additional hypotheses, including many that they had not previously thought of. For example, the customer suggested correlating business-related information with data from a mobile app to get new insights. In particular, we imported log data from a social mobile app that allows drivers to warn each other about dangerous conditions on the road to see if we could improve accuracy of claims investigations. The DataWalk system is highly scalable, so analyzing even large IoT datasets is no problem. Next, we modified analyses from the previous day by applying additional filters using data from this mobile application. We were able to identify only those claims where at the time of the reported accident there were many other drivers in this area, but none of them reported accidents. Later, we added a new data source, police reports associated with our claims, and extended the previous analysis to identify claims where there are not only other drivers around and no accident reported, but where there was also no police report filed. This again reflects how analysts can quickly ask and answer any question without using either SQL or a programming language. We quickly narrowed down from 3,000 identified claims to prioritize the top 20 for further investigation. Then users were able to check any details associated with these claims, and when appropriate, block any compensation processes related with them. On day 3, we completed this POC by delivering a list of suspicious claims that came from testing the next 56 hypotheses. The net result of the exercise was that the customer was able to immediately identify the parameters of new types of suspicious claims and incorporate this into their existing production workflow with their existing toolset. By the conclusion of this 3-day POC, we imported and blended 9 data sets to test 98 hypotheses, and 42 of these hypotheses were validated and brought value by indicating at least 380 suspicious claims. This rapid prototyping immediately enhanced the customer's bottom line after just a few days, as they could instantly act to withhold payments on suspicious claims. Throughout this 3-day POC, the customer is working with real data and rapidly, iteratively extending a fully functional analytic environment. While traditional tools would take much longer to generate results and create just a particular analysis or workflow, DataWalk created a foundation to support unlimited, and even currently unknown, analysis projects.